Did you know that Google is expected to process around 5 trillion searches in 2025? Chances are you've used a search engine today, maybe to find the best deals online, watch a video that explains something from class, or even start looking into what and where you might study after high school. But have you ever stopped to think, why do some websites show up at the top, while others don't? Hi, I'm Ryan Admiraal, a senior lecturer in statistics and data science at Te Harenga Waka, Victoria University of Wellington. Let's explore a bit of the maths and stats that power your everyday searches online. One of the biggest breakthroughs in search engine tech was the PageRank algorithm. It changed the game by figuring out how to sort through billions of web pages and show you the most relevant ones. At its core, PageRank is all about connections, specifically the links between different web pages. It turns out that the way web pages link to each other can tell us a lot about which ones are more likely to be useful. Imagine the internet as a huge web of pages. Each page is a circle, and the links between them are arrows connecting those circles. Now, picture someone clicking randomly from one page to another by following those links. Over time, some web pages will get visited more often than others, just by how well connected they are. PageRank uses statistics to estimate the chances of ending up on each page if you were clicking at random like this. And when you search something, Google looks for pages that mention your search terms, and then it uses those probabilities to rank which ones show up first. For instance, let's say your search brings up 6 web pages. These pages are linked in different ways. To model this, we can create a simple diagram showing how each page links to others. From there, we turn this into a table, something called a transition matrix. Each row and column of this matrix represents one of the 6 web pages, and we use ones and zeros to show which pages link to which. Then we adjust those numbers so they represent probabilities. For instance, if a page has 3 outgoing links, each one gets a probability of 1/3. By repeatedly multiplying these probabilities, we can figure out which pages are more likely to be visited. And that's essentially how PageRank works out which pages are the most important. Now, with just 6 web pages, those calculations are pretty easy. But what about millions or maybe even billions of web pages? That's where things get quite a bit more complex and more interesting. Instead of repeating all those calculations over and over again, we can use a concept from linear algebra called an eigenvector. It's a clever shortcut that helps us get to the same final result, a ranking of pages based on their importance, but it does it so much faster. This idea isn't just useful for search engines. Eigenvectors in linear algebra are used in engineering, science, finance, and more. So the next time you search for something online, remember, there's some pretty cool maths and stats working behind the scenes to help you find what you're looking for. And if that kind of thinking excites you, there's a whole lot more to explore. Study for a Bachelor of Science at Te Harenga Waka, Victoria University of Wellington.